All right, the last reaction in this chapter is a special reaction. It's a pretty important reaction. It's what's called an acetylide ion. Acetylide ion, anion. What it does is it makes carbon-carbon bonds. Okay, it attaches carbons to other carbons. You're attaching carbons to other carbons. It's kind of what's called sometimes the holy grail of organic chemistry. Anytime someone develops a new reaction where you can make a carbon-carbon bond and extend a carbon chain or to make a cyclical structure, they usually get a Nobel Prize for it, right? That's how big of a reaction it is and how important it is to actually understand. Like if I start with 5 carbons and all of the reactions we learned so far, I still have 5 carbons at the end. My product, I've just added oxygens to it or I've cleaved it in half, but I still have the 5 carbons. This is I can take a 2-carbon chain and add any number of carbons I want to it. All right, I can add much more carbons. So that's why it's a pretty important reaction, and I kind of wanted to do it separately. All right, the first thing is what it uses is what's called an acetylide. It is a 2-step reaction. 2-step reaction. All right, and it uses something called an acetylide. An acetylide is it's a triple bond where one of the carbons has a negative charge. The other carbon has an R group. That's an acetylide. Anytime you see the ending of "ide" in chemistry, it means it has a negative charge, like chloride ion, oxide. All right. Anytime you have the "ide," it means you have a negative charge, acetylide. And acetyl group is a C triple bond C. So that's where you get the name. So this is a very good nucleophile. It's one of the best nucleophiles ever. Anytime you have a carbon negative, you've got a good nucleophile. The way that you make this, you don't just buy these, you actually have to synthesize it and use it, is you start with a terminal alkyne. All right, we've talked about what terminal alkyne is. Terminal alkyne, it's an alkyne at the end of a chain. You have to have this hydrogen. The reason is because that hydrogen is slightly acidic compared to other hydrogens. So if you add a base to it, the base used is sodium amide. The sodium, remember, is the spectator ion. Oh, that should be a 2. There's a spectator ion. You have these extra lone pairs with a negative charge. That's really the base. This is acting as our base. Right? This is the reagent you buy. It's a white solid. You can buy it. It's stable. But the sodium is the counter ion, so it's not really part of the mechanism. What basically happens is this base comes over, plucks off the acidic proton. These electrons then go on the carbon to form your acetylide ion. So that's what you have to do first. You first have to make your very good nucleophile. Once you've made it, the second step is reacting this with some sort of alkyl halide. Alkyl halide. And the important thing to know, this is very important, is that the carbon on this alkyl halide has to be sp3. Has to be an sp3 hybridized carbon. So your carbon has to have a halogen. And remember, your halogen is either bromine, chlorine, or iodine. Okay? X is either Cl, Br, or I. But this carbon right here has to be sp3. If it's sp2 or sp, this reaction will not occur. So, you take your acetylide ion, add it to your alkyl halide, and what happens is these electrons go to the carbon and kick out your halogen. And what you've just done is made a carbon-carbon bond. So this carbon on your triple bond now gets bonded to the other carbon. Right? The halogen, the X, bonds up with the sodium from the sodium mid, and you form sodium chloride, or sodium X, whatever your X is in this case. All right? But again, that's not the important thing. I don't care about that. This is the important thing. You made a carbon-carbon bond. You've extended your carbon chain. Okay, that is very important. So let me show you a real reaction. If you take propyne, right, add in sodium amide to form the acetylide, and then you take that and react it. Let's say we reacted with isopropyl chloride. How about that? Use a different compound. Put PR. Your product is going to be CH3, C, triple bond C, C, CH3, CH3, CH3. That is going to be your product. All right? So basically what you've done is this carbon right here bonds to this carbon. This whole group gets attached to it, and the bromine leaves. So this big chunk is from here. Whatever that group is gets attached. And you can see, you can put as many carbons as you like, make it as big as you want. Okay? Another way of doing this is just to kind of, I'm just showing you another way of writing it. All right? You can do 1 NaNH2, and then 2, whatever your alkyl halide is. Let's do cyclohexyl iodide. All right, rather than writing it all out, you can just do a 2-step process like this and just write out the reaction, and then your final product will look like that. Okay, I do want to say this. I don't know if I said it at the beginning of the chapter, but these reactions, I'm going to let you have a note card on the exam of just the reactions, not the mechanisms. We'll talk more about it in class, okay? But just to let you know, it's not like you got to memorize these. You have to know what the products are and what the mechanisms are and understanding the chemistry, but a lot of these things like the NaNH2 and the BH3 and the H2O2 and sodium hydroxide, there's a lot of the details, and I don't expect you guys to memorize all throughout the semester, so I'm letting you have the note card so that you don't have to memorize all the details. You still have to know what the reactions do, and you got to know what the mechanisms do, but I'll let you have a note card of just reactions, not of notes, but of reactions. And like I said, we'll talk more about it in class. Okay, so this is the acetylide reaction. We will talk a lot about this next time in class. I will also have additional problems. We will also do something called synthesis problems. This is a big deal in this class, and in this chapter, because we've just learned a whole bunch of new reactions, we can now start applying them to what's called a synthesis reaction, and we will talk about those in class.